Today we are going over applying algebra, how we can see it in the real world. A lot of it deals with story problems, maybe using formulas, setting up equations. This first example deals with distance. So the driving distance between Boston, Massachusetts and Cleveland, Ohio is about 660 miles. If you drive this trip in a total of 12 and a half hours, what is your average speed? A lot of people can actually look at this and say, okay, well, if I'm driving 660 miles and I go 12 and a half hours, I'm dividing. So they would already, a lot of people could just say, okay, 660 divided by, sorry, I don't know what happened there. So 660 divided by 12.5 to get 52.8 miles per hour. Okay, you might, some people need like a formula to use. Well, we have a distance equals a rate times time formula. Our distance is 660 miles. Our rate is our speed, we do not know, and our time is 12.5 or 12 and a half hours. So we would have to think about, this is a one-step equation. How do we get R all by itself? Divide by 12 and a half. Okay, really we're doing the same thing. You can see the R is all by itself, so now we can find our rate to be 52.8 miles per hour. Okay, so if you need a formula, we can use that distance equals rate times time formula. The next problem deals with writing equations and then plugging numbers in. We're going to take the information from this table and be able to write an equation. Okay, so first we have to look, okay, what is our starting time? This table shows the height of a jet airplane T minutes after beginning its descent. So we want to know how long it will take for this plane to come down and land. Write an equation. Remember, equations have equal signs. Okay, expressions do not. Write an equation to represent this situation. And I'm going to move this down a little bit so I have some room here. So y equals, well, look here, we have a starting point. Just like if you go out on a drive or go for a run, you have to have a starting point. Where are you starting at? Here, we're starting at 0 minutes, we're at 35,000 feet. Okay, so that is our starting number. Now if you look from each minute, look to see what your difference is. 35 to 32, you're subtracting 3,000. Same thing, 32 to 29, minus 3,000. You want all these changes to be the same. Okay? If you notice, between all three of these, or between all five of these, their difference between each other is the same. So we are subtracting 3,000 feet every minute. We do not know how many minutes total it'll take us, so we are going to use a variable, and we can use x, or you could use t. So there is our equation, the first part of that. The second part says find the height of the airplane after 9 minutes. So all we have to do is plug 9 in. And we're going to plug it in for x. So y equals 35,000 minus 27,000. Get y equals 8,000 feet. If you notice, I have labeled it. Okay. Here, there's two things that we had to do there: write an equation and evaluate it. Now, if you want to just double check this, plug in those numbers for time for x. So plug 0 in. 0 times 3,000 is 0. So you're left with 35,000. Yeah, that's what we got. Plug 1 in. 1 times 3,000 is 3,000. 35,000 minus 3,000, 32,000. Okay, so that's where we're getting those numbers. Let's look at another problem like that. We need to write an equation first. So remember, equations have equal signs. So y equals. Now, our starting point, time. Our time is 0. When our time is 0, we're at 2,400 feet. Okay, so this person is flying. They're at 2,400 feet at a specific point in time. 1 minute later, they're 2,190. 2 minutes later, 1,980 feet. Okay, so we are subtracting. Okay, we are subtracting between all these, and I want to look. We are going down 210 feet each time. Okay. So we are declining 210 feet at each interval. So we're going to subtract 210, well, each interval or each minute. We don't know how many total minutes, so x. There's our first part of our answer. The next part says find the height after 8 minutes. So I need to find the height after 8 minutes. I'm going to plug 8 in for x. Okay, so y equals 2,400 minus 210 times 8 is 1,680. So y equals 720 feet after 8 minutes. So this person, they would decline 210 feet per minute. After 8 minutes, they would be at 720 feet off the ground. Okay, when they started at 2,400 feet. The next problem deals with painting. A lot of people use these. Use this to be able to draw stripes, or vertical stripes, or even horizontal stripes to paint their walls. For example, you want to paint five 1 foot wide stripes on the wall. There should be an equal amount of space between the ends of the wall and the stripes, and also between each pair of stripes. The wall is 14 feet long. How far apart should the stripes be? Now, one thing I am very fond of is drawing pictures. Okay, drawing pictures helps me see what's going on. So, for instance, I am going to draw a picture of a wall. Okay, so I'm going to draw a rectangular wall. Now, we want 5 stripes in between. Okay, so we aren't starting at the corners. We are going from, we want equal space in between. Now, I don't know how well my stripes will be. Okay, how equal. I'm not that great of an artist. So there's 3, 4, and 5. Okay, these represent the stripes of that wall. Now, each one of those is 1 foot long. The total length of the wall equals 14 feet. Now, the space in between the stripes in the wall, we do not know what those distances are. Okay, those are unknowns. So I'm going to use a variable, x. And each one of these is the same distance. Okay, so I'm just going to put an x there because they're all equal. Now, I'm going to write my equation. We have 1, 2, 3, 4, 5, 6 x's. Plus 1, 2, 3, 4, 5 stripes. And that equals a length of 14 feet. Now we can solve this. Okay, we got it set up. It's a 2-step equation. So I'm going to minus 5 from each side. So I subtracted 5 from each side, so I have 6x. I have no idea why that 5 is there. Equals 9, and then divide by 6. So x equals 9 over 6, or 1.5, or 1.5 feet. Okay? So we drew a picture to help describe what's going on. I think that is a great thing to do. Okay, from there I can tell I have 6 x's. Each one of those strips is 1 foot long, so I have 5 feet, and I want that to equal a total length of 14 feet. Okay, so let's try this next one. It's very similar to that last one. It says you are hanging 3 championship banners on your wall in your school's gym. Maybe you might see what this looks like, or have seen what it looks like. The banners are 8 feet wide. The wall is 62 feet long. So first, I'm going to draw a wall. Okay. Then I'm going to draw a banner, 3 banners. Okay. There should be an equal amount of space between the ends of the wall and the banners, and in between each banner. So very much similar to that last problem. So I'm going to draw a banner. Here's 1, 2, and 3. Okay. So now each banner is 8 feet wide. We do not know what the space is in between the banners, but we do know that they are all equal. Okay, so I have these x's here, and this total length is 62 feet. So now I have this information. I can start to write my equation. I have 1, 2, 3, 4 x's. Okay, so 4x plus, well, I have 8 plus 8 plus 8, so that's 24, equals 62. It's a 2-step equation, just like that last one. I'm going to subtract 24 from both sides. Get 38, and then divide by 4. So x equals 38 divided by 4 is 9.5 feet. All right, there's story problems, applying algebra in a little sense, okay? It's not, there's other ways that we can apply this algebra. We'll get into that tomorrow. You'll see a lot of other different problems, okay? Have a good night. Talk to you later.